Okay, we got this thing, this new gadget here figured out. It's not only an attenuator, it's actually two attenuators in one package, and a set of 9 latching relays that control the various steps of attenuation. So let me show you what I got going on here. I've got the device here, and using the X1 to X2 ports going to the NanoVNA in a 2-port situation. I got a 12-volt battery. I determined on the back here that these posts on the back, like in the previous video, these posts here are meant to accept wires, and there's actually a coil in there. These are 9 different relays. So after looking at the resistance and figuring some stuff out and trying 5 volts wouldn't pull them in, so 12 volts pulled them in nicely. So they're 12-volt relays, and they're latching. So let me show you what I mean by that. Hang on. Okay, so for example, if right now it's in the default no load condition, none of the relays are active, everything's just kind of resting. And if I look at the NanoVNA, the top is gain, which is right at 0 dB. Sorry for the tilt here, but I'm doing the best I can with this situation I'm into. And the bottom is VSWR from 1 megahertz to 900 megahertz. And that SWR is, I don't know if you can see the red line there, but that's the 2-to-1 line. So it's under 2-to-1 all the way out to 900 megs with 0 attenuation. Okay, so back to this gadget here. If I turn on what I call the first relay, I take the positive 12 volts and I just touch that terminal one time, and you heard the relay click, and when I remove the voltage you didn't hear it unclick. So if I go over here now, hopefully you can read that, that's minus 4 dB. Now if I want to click it out, I have to reverse the polarity. So I reverse the polarity. You heard the click. I go back to the NanoVNA, or back to 0 dB of attenuation. So that's how this gadget works. So let me do some clicking here and show you what I mean. So the first relay was 4 dB. The second relay is 40. So I should have minus 44 dB now. And if I go over here, that's what I got, minus 44 dB, and still really good SWR all the way out to 900 megs. So I move over to the next one. This is minus 10 dB. Click, minus 10 dB. Now I should have minus 54 dB here, and that's pretty much what I got. At least over the HF range, which is all I'm interested in. The next one over is minus 20. So now we should be at minus 74 dB, and it's flopping around a little bit, but at least over the HF range, that's what it's at. There, it's stabilized. And you know, we're getting down to the limits of what the NanoVNA can actually display here, seeing as how it's not a precision piece of test equipment. Okay, there's another one. I forgot where I'm at. I think that's 20 more dB. Now it's pretty much starting to look like an open circuit. So let me just continue on here. There's another section. That's like, anyway, by the time we're all done here, we can have about 145 dB of attenuation cranked in. If I go over here now, after I click those next two, it pretty much looks like an open circuit. And that's not focusing very well. Stand by. Okay. So, let me turn all of these off that I had turned on. We'll get back to the normal condition here. And in order to do that, I have to reverse the polarity and hit it with some voltage just one time. And the relay will latch into that new state, which is kind of cool because it doesn't draw any current in either of the latched positions. This is a very high quality unit here. Okay, so let's see, where are we at? This tripod's giving me a fit. Now I can't seem to focus, but we're back to zero. Back to zero. So hang on. Okay, so here's the quick rundown. Relay number 1 is 4 dB, 2 is 40 dB, 3 is 10 dB. The next one is 20 dB, 40 dB, 1 dB. Skip this one for a second, jump over here. This is 20 dB and the last one is 10 dB. This relay here, I guess number 7, connects the second BNC connector here to the output here, and it also activates the last two sections of attenuation. So if you click this relay, you have a choice of either -20 or -10 or the combination of two for -30 dB from this second input port over here, which they call X3. So hang on. Okay, so I've got the NanoVNA now connected between X2 and X3. And if we check out our screen here, hopefully we can get it in focus again, and I think it is. Oh, got a loose mount here. Yeah, good enough, you can get that, I think. You can see it looks like an open circuit because the X1 input port is still connected. So if I come back here and I go to relay number 7 and I latch it on, heard the click, it's latched on. We come back over to the NanoVNA, and now bingo, we got 0 dB of attenuation and fairly good looking SWR, especially at HF. So the last two sections there were -20 and -10 dB, so let me click in -20, and there it is, -20, and I can click in the -10 for a maximum attenuation of -30 dB from those two ports. So that's it. There's a little project in the works to make this a useful thing, but I'm pretty impressed. And I don't know much honestly about Arduino, but this smells like it may force me to get involved with the Arduino thing, you know, for switching the polarity of those voltages and dialing in any amount of attenuation you want, all the way up way past 100 dB, plus switch between those two different ports, I think is pretty cool. So I will find use for this in the shack. Anyway, mystery solved. Keep tinkering. See y'all later.